We've now moved on to the project for the errors and exceptions. We're going to complete these following exercises. So number 1 says, in separate cells, have Python raise each of these errors. Do this without raise. So a syntax error, well, we can just write something like this. That is missing a parentheses. There's just so many ways to write a syntax error. So that's a syntax error. Let's do an indentation error. So we could just do this. We can have an indentation where one should not exist. So like that, that's an indentation error, right? So if you write Python code, each line must appear right below it when it's in the same block of code. You could do this in another way. So if a equals 10, we could have proper indentation. And then over here, we could have improper indentation within the code block. So the indentation error happens here. This is correct indentation, like that. So it only happens here. It says line 3, and it'll point right to it. All right. A name error, that's just using a variable name, say foo, that does not exist. That's how you get a name error. Then an index error, that's when you have a list like this, and you attempt to access an item in an index that does not exist. So that is index error. Index 9 does not exist. The key error, and then type error and value error. Those are the next ones. So a key error is with a dictionary. So we've seen this. We have a dictionary. Here's our dictionary. We try to choose a key that does not exist, like C. Even if we choose a number, Python is treating this as a key, so it looks for the key for, which is a possible key. It just doesn't exist. This is not an index error. Next is a type error. So a type error, we try to add two things that are the wrong type, like this. That's how you get one of many ways to get a type error. And then a value error, we learned there's a number of ways to get a value error. Just one way is if you're trying to find a value in a list. So say we're looking for the number 99, it does not exist, you get a value error, right? So value errors are when the value is, or the type is correct, but the value is wrong. Here, it just can't find that value 99. All right, exercise 2. Use the raise keyword. Using the raise keyword, raise a value error providing a message. Okay, this is pretty simple. So you just do raise value error. You can tab complete that. Python knows this is in your namespace. This is built in. And we'll just say some specific error here for the user. All right, so it raises the error. Moving on to number 3, complete the following function named checkArray that checks whether the passed argument is an array. So let's just take a look at this real quick. So we need to fill this out. We're going to delete the pass statement and just complete it. So here's what it does. It accepts a single argument right there. It's going to be, it says a list. It raises a type error with a descriptive message if this argument is not a list. So we just check, the first thing we check is that if this is not a list, then we raise a type error. So this has to be a list. Then check that each element in the list is of the same type. Okay, so we have to go through one by one each item in the list and make sure it is the same type. Raise another type error with a different message if the elements are not all the same type. Assume that the array always has at least one element in it, and then test your function by running the unit tests. There should be no output if answered correctly. So what this says is you'll run this if you run this block over here, and there should be no errors. There is an assertion error. So there are 3 tests over here. This uses the built-in unit test. We talked about this previously. Not built-in, sorry, but the standard library. The unit test is part of the standard library. So these are 3 different tests. It has to pass all 3 of these. So this test, if there's a test that an error actually is raised, you have to raise a type error. Then you have to raise another type error if basically you get an array, but there are different types in the list. And then this is if just nothing happens. So if it's correct, the function will return none. That's what that does. All right, so let's go through here one at a time. So the first thing is raise a type error if the argument is not a list. So we're going to use is instance. Is the array a list? Okay. If it's not a list. So it's saying if it's not a list, you can almost read this like an English sentence. If not, is instance array list. Okay. So if the array is not a list, then we raise a type error and we give a descriptive message and we say array is not a list. And we can actually be even more specific and say array is a type array. So we get the type and we say must be a list. Okay, so we can run this and we can see that now it is passed this one. So we pass it in a string that's not a list. So we've passed one of the tests. So that is good. Now let's go on to the next. Now then we have to check that every item in the array is the same. So it's got to be all the same. It doesn't matter what they are, just the same. So we could say first type equals type array 0. So this is just a list, right? So I'm going to get the first item. I'm going to get the type of it. I'm going to say that's the first type. Now I'm going to iterate through all of the items. I'm going to say for val in array. And really from one, I can filter, or not filter, I can slice it, say from the first to the end. And then I could say if not is instance. I'm going to do the same thing. If this value is not of the first type, then I raise another type error, I raise a different type error. And I say, we could just say value is of type. I'll just make it, for this one, I'll just make it simple. I'll just say all values must be the same type. Okay. So now let's execute this and let's test everything. So it actually works. So it actually works now. That's all I really need to do. So if I pass in this list over here, they're all the same type. So 5, 10, 3, and 2, these are all integers. So now I've actually written this correctly. So again, there's two checks. One is that this is a list. If it's not, it raises this type error. Then it goes through one value at a time in the list. And it says, if it's not the first type, so then we're going to raise a type error. So they all have to be the same as the first type, which just means they're all the same type. And that's how you answer that one. Moving on to exercise 4, complete the following function named get that finds the highest or lowest n values of an array. It accepts an array, an integer, and a string that's either high or low. So here's the array, here's the integer, and here is a string that will be either high or low. Notice that it describes this here in the parameters section of the docstring. So the idea here is that it's going to receive an array. You have to look over here is high or low and get the highest n or lowest n. So if this is 3, we say, all right, we want to get the highest 3 values or lowest 3 values of this array in sorted order. So that's the other thing. So we're going to use the check array function from above to ensure that the first argument is an array. So we're going to use that function we just created. We're then going to raise errors if n is not a positive integer. So we can't, if someone says -2, that's not correct. That's not going to help us out. So we're going to raise a value error there. This is a wrong value. We're going to raise another error if part is not the string high or low. So this can only be high or low. If anybody inputs anything else, that will be an error. And then what we're going to do is make sure to return the correct result, a sorted list. All right, so we're going to do this the same way as we did before. We're going to have all of these tests over here. So the first thing we're going to do is just check that the array is correct. So that's what we're going to do here. And let's just go ahead and test this. And so we passed the first 2 tests here, line 2 and line 3. So we get this and get that. That's just, we get that automatically because we wrote the check array correctly from above. Now we're over here and we're getting, we have to raise a type error because now n is, I said n is the string ASDF. That's not correct. N has to be an integer. So we have to check the type of n. So we can say if not is instance n integer. If it's not an integer, then we're going to raise a type error. And we're going to say n must be an integer. So let's run that. And now we can see that, all right, we passed that test. All right, now we're down to line number 5 over here. N cannot be negative. So we have to test if this is going to give us, we have to make this a value error over here. So if n is less than or equal to 0, so it can't be 0, it's got to be a positive. Then we're going to raise a value error here. Say n must be a positive integer. Okay, let's run that. And so now we're down here. So we passed this test right here. Now we're over here. And we're going to give it a wrong value over here. It's got to be high or low. Now we have to check part. So we validated array, we validated n. We're now going to validate part. We're going to say if part not in, if it's not in high or low, it's got to be one of those. That's what the documentation says. So right here, I'm creating a little tuple, creating a tuple like in a line. I'm saying if it's not one of these, if it's not in the tuple, right, then I'm going to raise a value error. And we're going to say part must be either high or low. And now it's passed these over here. And now we actually have to return the correct answer. So now we've done all of our checks. We've checked array, we've checked n, we've checked part, and now we're going to just return. So we're going to sort this list. So we're going to create an entirely new list, return a sorted array. And actually we need to do something else here first. So if part is, if it's high, then we will, sorted has this parameter called reverse. So by default, it goes from, it's an ascending order. So it's going to go from lowest to highest. So we'll keep reverse as false. We'll say reverse equals, we're going to create a variable here. Reverse is false. If it's high, I'm going to say reverse set to true. So we can put a little space there to separate this logic. So this is all of our checks. This is where we actually do the actual, task that it's asking for. So reverse is false. That means it's going to, by default, it's going to sort it in reverse order. But if part is high, then it's going to change that. So what we're going to do is just going to assign reverse to reverse. So this is the parameter name reverse. This is our variable name that we created over here. And then all we want is the first n numbers. And that should do it. So this will check. So if we give it this array, 5, 3, 8, 2, 4, 5, 10, 3, the highest two are 10 and 8. That's what it's going to do. It's going to check here. And then the lowest 3 over here are 2, 3, 3. And it passed those tests. All right. So that was there's a lot of things to do here. Not a tremendous amount of code, but talking through it, it took a while. But that was a good problem to check all of the inputs, array, n, and part, raise errors if there's wrong, if the user has given wrong input, and then to actually do the problem. So everything before this, errors and exceptions, we just did this part. We just assumed that the input was correct. So now we're taking we're doing a little more checks on our own. We're not assuming the user will provide us with perfect input. And then we actually complete the problems. All right, so that was exercise number 4. We're now down at exercise 5. It says attempt to write a try statement without a corresponding except statement. What happens? So you have to have except with try. So you can't just have try by itself. You can't have except by itself. So here we're just going to just make a very simple thing. Let's just have one line over here. So if we don't have anything, you're actually going to get a syntax error. So it doesn't even attempt, it can't even run this code because it's just invalid Python. you have to have an except here. Even if nothing happens, you can put the pass keyword, which means do nothing. So you have to have except with a try. All right, moving on to number 6. Complete the following function named add that attempts to add together its two arguments if possible. If not possible, print a message to the screen with the type information of each argument. Use a try except block. Return the value if able to be added, and none if there is an error. Okay, so we're just going to catch an error over here. And here is our assertions. So we're going to try, it's the first time we're doing this here, we're going to try to add this together. We can actually have return A plus B. We can just do it in there. Except, we're going to accept a type error here. That's, remember, it's good. You have to accept, it's good to just accept a single error at a time. And if it's not possible, we're not going to actually raise an error. We're just going to have a print statement. We're just going to print out cannot add together types. We'll just put the types over here. We'll say type A and type B like this. Okay, so here, yeah, 5 and 10, these are the correct types. That's 15. Notice it does pass these tests, which this is just printed out information to the screen. So that's all that happens here. So it has passed. There's no, notice that there's no exception over here. Then when it attempts to add 5 and 10, it says cannot add together types integer and string. All right, that is number 6. Moving on to exercise 7. Complete the following function named user_integer that asks a user to provide an integer. Retrieve this with the input function. Remember that this function captures all user input as a string. If the input can be converted to an integer, return it. Otherwise, repeatedly ask the user for another integer until one is given. All right, so before we actually run the code, I want to go over the input function again. So remember, this is how you can capture the user input. So we can say enter in an integer like this, and it'll ask this question. We can actually capture this in a variable like this. So again, if the user inputs it in, will be assigned to this variable over here. Now what we're going to have to do, what we want to do is actually convert it to an integer. Notice it is a string, so we can pass it to the int constructor like this and convert it. Now, if somebody enters in something that is not an integer, like these characters over here, and then we try to convert it, we're going to get an error. Notice it is a value error because you can actually, the int, you can pass it strings, obviously, like we just did here, like, 13 or something, it'll convert it to an actual integer. So it is not a type error, it is a value error. It's the wrong value. It's got to be a string with digits in it. So what we're going to do is now we can go back into the function, and we want to keep asking the user until they provide us an integer. So this is a while loop. So I'm over here. So what I'm going to do is say while true. So I'm always going to make this true. It'll always repeat, and then we're going to break out of here. So I'm going to use that pattern. That's not the only pattern. And in here, we're going to use a try except block. So we're going to try, actually first we're going to get the input, and then what we're going to do is we're going to try to convert it to an integer. So that's what we just did over here. We're going to try to convert it. We are going to accept a value error. All right, so that's the error that it comes over here, and we'll just print out a message to the user and say must provide an integer like this. And then if it makes it through, so then we can just return it. So we can actually use an else statement here. So remember, else only gets triggered if the try statement works. So it'll be successful. We'll just say return A like that. We don't even technically need an else statement, but just because, just I guess in the spirit of using what's available, we can formulate our code like this. Okay, so let's go ahead and see if this is right. There are no tests over here, so user integer we just run it without anything. And let's give it the wrong one. It says must provide an integer. Even if we give it like a float, that will not work. We have to keep going until we give it an integer, and then it will stop and return that number. So it's going to repeat this. So it's a while loop. So it just repeats it continuously. It's going to keep asking and asking and asking until we've given it, until this is successful. Once this try block is successful, it will go down here and just return A, which will break out of the loop. So hopefully you know that if there's a return statement in a loop, it'll actually just break out of there. So you don't even need a break statement. The return will do it for you. All right, so that is number 7. On to exercise 8. You're going to modify the myArray2.py module so that each function verifies the arrays are valid with the checkArray function. Find the solution in myArray2solution.py and test that your code passes the unit test by running python test myArray2.py. Use VS Code. All right, so I have VS Code open. This is how we normally have it open. We open up the Python fundamentals folder. Here's module 17. Click on myArray2 over here. This is the one you're going to modify. Right now, it has the answer to myArray from module 16. It's the same exact one. So all we're going to be doing is modifying this just a little bit, actually. And we're going to be using the checkArray function that we have in our solutions. But before we do that, we need to make sure that I want to show you the unit tests. So we have to cd into the current directory. And that way we can call the python test myArray2.py. And we can see here that it ran 10 tests. There's only one failure. So there's only one new test over here. You can actually open up the file where the unit tests are. There's one more test. It's just test all these. It puts in a bunch of bad arrays over here. You can see these bad arrays right there. So just make sure that it raises an error is raised. If an error is not raised, then then you haven't got the problem just right yet. So let me open this up, myArray2. This is the file we're going to change. And all we're going to do is just use this checkArray function to verify that they are working. And so we're just going to use this function and pass in the array like this. So in each function, we're going to call our function that we already wrote that will raise the type error. Now let me rerun these tests. It's still going to fail because it has to pass all of them, but it should be on a different line. So it says it failed on line 59. So let's go back over here. Here's line 59. So it failed here, right there. I don't know if it calls these all in the same order or not, why it didn't fail this one, but it should only have passed the add constant. But the way these tests work, this is just considered one test. I know there are many individual assert statements in here, but this is considered one test, even though there's multiple different assert statements. So all of them have to pass in order for the entire test to pass. Okay, so we can just copy and paste this, really. So that was an add constant. And this is repetitive, I know. And then, so once we get down to the add arrays, we need to check for both of them. So we need to check array 1 and array 2 like this. So now I'm going to copy and paste both. These functions get 2 arrays. So we're just going to copy or check both of them. And once we do that, then if we call this again, we should be able to pass all the tests. So it should raise errors for each one now. And that's what this test does. It checks every single, there's 9 functions. It makes 9 checks. And that's equivalent to just one test. So there's now 10 total tests. There's 10 functions here that are defined. Each function is a test. So that's all the solution is. You just copy and paste the check array that we already created during these exercises, and then you check the array. Now, we could also check the constant as well to make sure that's the same type, but we just are not going to do that here. I just want to show the main thing to show here is that the inputs, or at least one of the inputs, are being checked to make sure that we are verifying that the user is using our function correctly and its intended purpose, which is to pass in an array, and then it'll actually compute the actual calculation. All right, so that is it for number 8.